Hello everybody, welcome back to the CCNA routing and switching video series brought to you by ABY Design and Tech. You are joined here with your instructor Abdurrahim Chowdhury. We are going to be following on from the previous video and we're going to start focusing on the worker devices which serve a purpose in building the infrastructure allowing us to communicate over a computer network. In this video we'll focus on the function of a switch, what a switch is used for, and understanding how a switch performs its job. So the first question you guys are probably asking yourselves, what is the function of a switch? So what does a switch do? A switch allows you to build a local area network. More about local area networks later. But think of a local area network as being trapped on an island with your friends. So essentially, if you're trapped on an island with your friends, you're isolated from the rest of the world. The only people who you can communicate with are people on the island. It's similar to if we only had a switch in our network. So a switch allows devices which connect to that switch to communicate. Akin to the island analogy. So like with the island, if you're stuck on an island, you can only communicate with your friends which are on the island. Similar to if we only had a switch in our computer network. Switch only allows for communication between devices that connect to that switch, devices in the same local area network. Now at this point you're probably thinking that it's completely useless. Switch is no use. However, if you refer back to the previous video, I described how each of these worker devices specialize in some area of the network to provide connectivity from point A to point B. So because these devices have a specific role, it makes them very good at their role. So a switch provides, as example, just local connectivity. There will be another device specializing in providing connectivity outside of your network. So if we're going to use the island analogy, there will be another networking device specifically designed to allow, let's say, communication from your island to the rest of the known world. There will be a device specializing in protecting your island or protecting your network, etc. So it's very important to understand that these devices, they specialize in different things and they have a specific function which they perform. In this case, a switch's function is just to provide local connectivity, allowing you to plug devices into that switch, and then you can only communicate with devices which plug into that same switch, so physically connected to that switch. So now that we understand the function of a switch, we need to look at how does the switch do its magic. So how does a switch allow connectivity between devices that connect to that switch and are therefore part of the same local area network? Well, switches, let's talk about Ethernet switches, since Ethernet is the most popular protocol. A switch uses a protocol called Ethernet to allow communication between devices that connect to that switch. Ethernet is a protocol that defines the rules of how devices communicate in a local area network. It's similar to having driving laws. So think of it like this. We have roads in our country to allow us to essentially travel between towns and cities. They are the infrastructure allowing us to get to where we need to get to. However, we can't just start driving on the road willy-nilly in terms of we can't just do whatever we want on the road. So we can't just go at whatever speed we want. We can't just drive on whichever side of the road we want to. There are laws in place dictating how fast we go down certain roads, what side we drive on the road, and also just general rules and practices of driving on a road. Similar that with computer networks, we have these physical devices. So we have the cabling, we have the physical infrastructure to essentially allow communication between computers, between phones, etc. But there has to be some rules, some guidelines in place to define how we can use that infrastructure to then communicate. So now you're thinking, okay, so we understand that Ethernet allows devices to communicate. Essentially, Ethernet, we'll look more about Ethernet later, and we'll have a deep dive into how the Ethernet protocol works. But just for now, just to remember that Ethernet is a protocol which dictates rules and guidelines that devices must follow that connect to a switch, that connect to a local area network in order to communicate with each other. It's as simple as that. It's as simple as how we need to abide by laws when we drive on the road to ensure that we're driving on the correct side of the road and we're driving at the correct speed limit. Now going back to our desert island example, We're on the island. Now, how do we communicate with our friends? So the devices in our network, okay, they plug into the same switch. How do those devices then communicate? How does, let's say, Bob, who wants to communicate with Brad, they both connect to the same switch. How does Bob signal to that network switch that I want to communicate with Brad? Now, if we go back to our island example, how do we communicate with our friends? Simply, we just refer to our friends by their name. So as example, I'm like, hey Bob, or hey Brad. I refer to my friends by their names so they know who I'm talking to. And to be fair, that's exactly how Ethernet works. So Ethernet communicates using something called a MAC address. Now you could think of a MAC address as like your social security number or your national insurance number, in that it's unique to every single device. So every single device in the world is going to have a unique MAC address, which is specific to that device. Now the MAC address follows the following format. So this image down here was captured by using the command on Windows command prompt ipconfig/all. There's a whole bunch of settings, but just to focus in on one setting, this is the physical address. So the MAC address can be referred to as the physical address, and all it is just a 12-digit hexadecimal number used to uniquely identify that device on the network. The good thing about MAC addresses is that it's unique to each device, which is where our analogy falls apart in terms of with our friends, because obviously our friends can have first names exactly the same as people who live halfway across the world. However, with the MAC address, you could take a computer from the US, you can unplug it, you can move that computer to a network in the UK, and guarantee you that once you plug it into that network, no other device on the network will have the same MAC address. The MAC address is unique to each device. Okay, so now that we understand that we use MAC addresses to communicate, and that a switch knows where to send packets next based on the MAC address, how does this magic work? So, like I said before, the MAC address is the name of your device. It's a unique 12-digit hexadecimal number used to uniquely identify that device on the network, and it's essentially that device in the world. It makes sure that when you send data that it goes to the correct device. So we use MAC addresses so that when Bob wants to speak to Brad, the switcher knows that Bob only wants to speak to Brad, and for example doesn't send it to the data to Sally. Now, MAC address is locally significant. We'll talk more about this later, but essentially it's only used to communicate on the same network. So devices will only use the MAC address to communicate with another device on the same network as itself. So let's see an example of this magic in action. Okay, so this shows the switch in action. So as you can see, we have Bob, which plugs into the switch, Brad, which plugs into the switch, and Rick, which plugs into the switch. So like I said before, switch, because Bob, Rick, and Brad are plugged into the same switch, they can communicate with each other. This is very similar to our island example, where you can only communicate with your friends on the island because you're essentially isolated from the rest of the world. So when Bob wants to communicate with Brad, it's going to send some sort of data to Brad. So in this example, imagine this is an email. So Bob wants to send an email directly to Brad. When Bob is going to send that data, again, we'll talk more about this in depth later, but it's essentially going to encapsulate. So think of it as putting that data into an envelope. So when you send a letter, obviously you write the letter, you put it into an envelope, and then you write the address. So you write the from address and you write the to address. The to address is going to be where that letter is going to. The from address is going to be your address, the address that you're sending it from, just in case they have to send that letter back, or to be fair, any package back. So in this case, Bob's going to take that data, put it into an envelope, and on that envelope it's going to write where that data is coming from, so the source MAC address to identify itself, and the destination MAC address, where that data is going to. It then sends that data, it travels over the wire all the way to that switch. That switch, again we'll discuss this a bit later, then knows, okay, to reach Brad I have to send this data out the physical interface on my right. So he then forwards that traffic all the way over to Brad. Now, Brad knows the MAC address of Bob because the frame that it received, so the data that it received, if you go back, was sourced from Bob's MAC address. So now Brad knows that it can reach Bob by sending the data, so in this case this is a return email, to destination MAC AAAA. And again, it's going to source this data. So essentially, imagine that you were putting this data into a letter. The source address is going to be its own MAC address. And again, when the switch receives this data, it knows that in order to reach Bob, I need to forward this data out the port on my left. Okay, now I know what you're thinking. Okay, you're thinking, okay, essentially this is quite simple to understand. Again, switch just allows connectivity between devices on your network. It works based on MAC addresses. MAC addresses are unique to every single electronic device, and the switch knows that, okay, I can reach, let's say, Brad via this port, Bob via this port, based on the MAC address. However, that's where probably you're struggling now, that you're thinking, okay, well, how does the switch know that it can reach Brad on the right? How does the switch know that it can reach Bob on the left? Okay, so this is a very important point. A switch will keep a table known as a MAC address table. This is stored in memory, stored in something called content addressable memory. Again, we will address this later on in the series. But essentially, what the MAC address table is like is it's as if you created a book listing each neighbor in your neighborhood and their address. So essentially, you're creating a book and you're listing each neighbor. So as in this example, let's say Rick, James, Brad, etc. And you're saying, okay, Brad lives at so-and-so address. Rick lives at so-and-so address. So you got this book and you know how to reach each individual person because you have the home address. Now this is very similar to what a switch does. So the switch is receiving frames. So in this case, it's receiving frames from Bob, it's receiving frames from Brad, it's receiving frames. So again, all a frame is, but I don't know if I clarified this earlier, a frame is just a piece of data which has been put into an envelope and now has a source and destination MAC address. Again, it's, to be fair, it's a lot more complex than that, but we'll go into this later. So this switch is receiving essentially data all over the place from Bob, Brad, Rick, etc. And then as it's receiving that information, if we go back to the previous slide, as we can see, all the data that Bob sends, that Rick sends, that Brad sends is going to be sourced with their MAC address. So what the switch does, it essentially looks at this data that it's receiving, takes a note of the source MAC address and takes a note of where it received the data from. This is how the switch would build its book listing everybody that connects to that switch. And you could think of a switch's function as if the switch was an office mail worker. So what does an office mail worker do? So a mail worker who just sticks in the office. Essentially, that mail worker, so imagine you are the mail worker. Your job is to sort the letters into different piles, into different bags, to ensure that the letters, the packages are put in the right pile or put into the right bag so they get to the correct location. That's essentially what a switch does. Switch just ensures that as it's receiving data, it sends that data out the correct interface so it reaches the correct destination. And so this diagram shows the MAC address table, or as I like to call it, the all-knowing table. So the MAC address table, as you can see, is built like this. So it lists the MAC address and also the port that device can be reached from. So in this case, the switcher knows, okay, I can reach Bob, who's got MAC address AAAA via port 1. I can reach Rick with the MAC address BBBB via port 2, and I can reach Brad via port 3, as Brad has the MAC address CCCC. So the way, again, like I said before, the way that the switch populates or builds this table is that as Bob, Rick and Brad, it's important to know that networking devices, or essentially like computers, laptops, they're always active on your network. They're always sending and receiving data, always sending and receiving some sort of information. So Bob, Rick and Brad, they're always going to be active on the network. They're always going to be sending data. The switch, as you can see from this data coming into here, the data is always going to have a source MAC address, and that source MAC address is always going to be of the person who sent this. So in this case, Bob's going to list his source MAC address. the switch, when it receives this data, it looks at the source MAC address. Okay, A looks at, okay, I received data from this source MAC address coming in via port 1. I'm going to add this to my MAC address table. Same thing with Brad. If Brad were to send some data, the switch will look, okay, I received data with the source MAC address CCCC coming in via port 3. I'm going to add this entry to my MAC address table. It's literally as simple as that. And to be fair, that all there is really is to it. So we've reached the end of this video. Essentially, just as a recap, we've described that a switch just focuses on switching data from one device to another, as long as the device is connected to that same switch or connected to the same network. A switch equals a local area network, and we've seen how the Ethernet protocol, which we will go into more detail on, can be used to send and receive data because it defines the rules and guidelines devices must follow to communicate. Thank you for watching. Again, if you want to see more content like this, then please subscribe to my channel. Please share this video with the masses so that we can, like I always say, get free high quality training to the masses. Thank you very much.